So here we have a function, a square root function, which is y is equal to the square root of x minus 1. In this case, we had a k of -4, but in this one, in 3b, we have an h of -1. And so let's go ahead and see what that does to our graph. The domain of a square root function is always the same. It's x such that x is greater than or equal to 0. So then we can go ahead and start our chart. So let's do x and y. Start it at 0, 1, 2, 3, and 4. And so I'm going to go ahead and break out my calculator. So square root of 0, when x is 0, we have a square root of -1. So that does not exist. Okay, so maybe I overspoke when I set the domain to x is greater than or equal to 0. So because that creates a square root of a negative number, x is equal to 0 doesn't exist on this graph. So let's start with x is equal to 1. We're plugging it in and we get square root of 0. So y is equal to 0 when x is equal to 1. And then we go ahead and substitute in 2, so we get the square root of +1 is going to be 1. And then we get a square root of 3 minus 1 is square root of 2. So let me go ahead and get out the calculator. That's 1.14. I'm sorry, 1.41. And then we'll do a square root of 4 minus 3. So square root of 3 is next. It's 1.73. So let's go ahead and graph that. So we're here at x is equal to 1, y is equal to 0. We're at 2, and y is equal to 1. At 3, y is equal to 1.4. And at 4, y is equal to 1.7. So we're about that right there. So we get this curve, right? The classic parent curve of the square root function. And our domain is not going to be x such that x is greater than 0. It's going to be x is greater than or equal to 1, right? And then our range is going to be y such that y is greater than or equal to 0. Because we could see here that our graph starts with y at y equals 0. So we're comparing with our parent function and what's happening. The graph, the parent function, is translated to the right. To the right by 1 unit. And so, that just shows us here that our h, if it is negative, it will shift our graph to the right by that many units. If our h is positive, then it will shift our parent function to the left that many units. And if our k, what does our k do? If it's negative, it will translate the graph downwards that many units. And if it's a positive number, it will shift it up that many units. Right? So that's what a, h, and k do to the parent function.